So today we will be discussing the next part. Okay. Good evening, students. Hope the question is visible. Okay. So we will be discussing the 5 mark question today. Okay, the 5 mark question on relation and function. Okay, in relation and function. So the question occurs on the concept of invertible function. Okay, on finding the inverse. So it is a mixture of two concepts here. Okay, so we will discuss it. So first we will discuss the
Sir,
concept.
1 minute, sir. My class, I just want.
Okay.
Sir, you can start, sir.
Okay, sir.
Yeah, Anand, I'm in a meeting. I'll call you back.
Yes. Okay.
You can start, Rohan, sir.
Okay, okay, sir. Yes. Good evening, students. So we will be discussing the 5 mark question, okay, which occurs in the board exam based on relation and functions. Okay, so this question is occurring from the concept of inverse of a function. Okay, so first we will try to understand the concept and then discuss the example. Okay, so if f is a function, okay, f is a function from a to b. Okay, if f is a function from a to b, okay, and g is a function, okay, from what b to a. Okay, g is a function from b to a, and if these two functions satisfy f composition g and g composition f. Okay, so if these two are equal to I, that is identity function, then we say f inverse is equal to what? G. Okay, so the function g will be the G will be the inverse of the function f if f composition G and G composition f, okay, is equal to identity function. Okay, if both are equal to identity function, okay, if both they are equal to an identity function, then we say f inverse is equal to what? G. Okay, f inverse is equal to G. So in this case, G is called as the inverse function of f. Okay, G is called as the inverse function of f. So now first, okay, there are two definition. Okay, the second definition, see, if f is a function from a to b, if f is a function from a to b and it is both on one and on two, if the function is both on one and on two, then such function is called as a bijective function. Okay, so if a function is bijective, then the inverse of the function, that is f inverse, will exist. Okay, f inverse will exist only if the function is one and onto function. One function ಮತ್ತು onto function ಇದ್ರೆ ಅಷ್ಟೇ inverse of the function exist ಆಗ್ತದೆ. Okay, so and if we need to find out the inverse of the function, okay, we can, to prove the inverse of the function, we are making use of composition, the property of composition of two functions, that is f composition G and G composition f. Okay, so if f composition G and G composition f is equal to identity function, we say that uh, G is the inverse of f. Okay, so to prove, to find out the inverse of the function, okay, we are making use of the property of composition of two functions. Okay, so we will be solving the 5-mark question based on this concept, that is inverse of a function. Okay, so a function is said to be invertible if its inverse exists. Okay, and for a function, for exhibiting the inverse, it should be a bijective function. If it is a bijective function, then the inverse, that is f inverse, exists. Okay, and to check and find out the value, okay, we are making use of the composition of two functions. Okay, to show f inverse is equal to G, we are making use of the property of composition to check the function G is the inverse of the function f. Okay, so with this concept, we will discuss the first question in today's class. And before going to the question, first we will try to understand. See, f is a function from what? Set A to set B. So the set A is called as the domain set. Okay, it is called as the domain set. ಇದಕ್ಕೆ domain set ಅಂತಾರೆ. ಮತ್ತು set B is called as the codomain set. Okay, codomain set. Okay, it is called as the codomain set. So whatever the x values are there, we are considering it from the set A, that is the domain set, and for every x, there will be some y present in what? B. Okay, and if this is a unique value, then it is said to be a one function, and for every element of B, if x exists, okay, then it is said to be a onto function. Okay, so whenever we need to remember, whenever we are considering x, we are always considering x from the domain set. Okay, so it's just like the input, so input we are taking from the domain set, and whatever the output we are getting, okay, y, and that must belong to the codomain set. So this y value is also belonging to the range. Okay, it is belonging to the range. Okay, and in case of bijective function, a codomain and range, both the sets, okay, both the sets will be equal. The range and codomain will be equal in case of bijective functions. Okay, in case of bijective functions, codomain and range will be equal. Okay, so the set y belongs to range, the element y belongs to range, and x we are considering it belonging to set A in all the examples. Okay, so using these concepts, we will try to discuss the examples. A 5-mark question from relation and function. So every year this question is occurring in the part D. The first question, I think the 39th question, always the 39th question is based on the same concept, that is inverse of a function. Okay, so this year they have deleted some syllabus also. Okay, they have reduced the syllabus. So either the inverse of the function question will be asked, or the question, the other form of the question is they will ask you to check whether the function is one or onto function. Okay, so both the questions we are discussing. So maximum time inverse of the function question has occurred, and even in the model paper 2024 model paper also the same question is given. The first question what we will be discussing, the same question is given here. Okay, in the model papers. Or instead of inverse of the function, the other question may be on checking whether the function is 1 1 and onto function. Okay, that is the second question. So either the question will be on inverse or check the given function is 1 1 or onto. Okay, so we'll begin with the first question. Okay, solution. So first we need to understand the question here. See, the function is defined from n to y. Okay, f is a function from n to y, that is set of natural number to the set y. Okay, and the set y is also given. Okay, y belongs to n such that y is equal to 4x plus 3, and the function, the definition of the function is f of x is equal to what? 4x plus 3. Okay, is the function given. So here what we need to do is, here two terms are very important here. The domain and range, that is the domain and range, it's already given in the question, and the definition of the function. Okay, so the definition of the function is what? How it is defined, f of x is equal to 4x plus 3. So here we need to show that f is invertible and also find the inverse. Okay, so first we have to show f is invertible. Okay, f is invertible, and then we need to find the what? Inverse of f. Okay, f is invertible and find the inverse of f. Okay, so to show f is invertible, we can show it is 1 1 and onto. Okay, to show it is invertible, we need to show f is 1 1 and onto function, and to find out the inverse, okay, we can directly do that. Okay, so see, the first what we need to do here is, okay, so we are considering the function. Okay, first we are considering the function. So consider f n to y. Okay, n to y defined as f of x. Okay, f of x is equal to 4x plus 3. Okay, now to check oneness of this function. Okay, to check whether the function is 1 1, we need to just, okay, we need to just what we need to do is make use of two elements here. Okay, so here to show oneness, we need to consider let f of x1 is equal to what? F of x2. Okay, so in the function where there is x, replace it by x1. So see, 4x1 plus 3 is equal to 4x2 plus 3. Okay, so 3 and 3 will cancel off, so it will be 4x1 is equal to 4x2, or x1 will be equal to x2. Okay, so what we have proved is, okay, uh, okay, for, see, f of x1 is equal to f of x2 implies we have proved it as x1 is equal to x2. So when this condition is proved, that is, the if images are equal, then the elements are also equal. Okay, so if we are proving this condition, then the function is what? A 1 1 function. So f is a 1 1 function. Okay, it is a 1 1 function. Okay, now next we, to check it is invertible, next we need to now prove it is onto also. Okay, we need to prove it is onto. Okay, this is the first step what we need to do. So we have shown x1 is equal to what? X2. Okay, x1 is equal to x2. Next we need to show it onto. Okay, so for onto, what we need to do is, we need to consider the given function. So consider, so this is for onto case. In case of onto, consider f of x, okay, is equal to 4x plus 3. Okay, so we need to convert this given function in terms of x. Okay, so the function is in terms of y now. Y equal to, we have defined the function, we need to convert it in terms of x is equal to, okay. So what we are doing here is y minus 3 is equal to what, 4x, okay, or x will be equal to y minus 3 upon 4, okay. So here we are getting x is equal to, say, x is equal to y minus 3 upon 4, okay. So this is nothing but the inverse of the function what we have obtained, okay. So the function is also what, onto, but to show it is onto, we need to write down a step, okay. We need to write a step, that is, let y be, okay, let y be a arbitrary element. Mhm. Okay, so we need to write down for showing the onto function, the statement. This statement we need to write down. Okay, let y belongs to, okay, the element y be an arbitrary, okay, element of range, okay. Range, here the range of the function is y, range y, then by definition, by definition there is y, okay, there is, okay. So by definition we need to write there is y equal to, there is y equal to 4x plus 3, 4x plus 3 for some x in the domain, what, in the domain set n, okay. Therefore we need to write down okay, in the domain set n, okay. Therefore, so see, whatever the function we have got here, and this I'll consider it as 1. So this equation 1, see, equation 1, x is equal to y minus 3 upon 4, okay. So this we need to write it down as f inverse. So see, f inverse of x, okay, is equal to, so here you need to write, okay, what we need to write, f is 1 1 and onto, f is 1 1 and onto, therefore f inverse of x is equal to x minus 3 upon 4, okay. So this is the inverse of this function, okay. F inverse is equal to x minus 3 upon 4, okay. So to show the function is invertible, first we need to show it is 1 1 function, and then we need to show it is onto, okay. So for onto we need to write the given equation in terms of x and show that for every y there is some x, okay. So if we, so this statement is very important, let y be any arbitrary element of range y, then by definition there is y is equal to 4x plus 3 for some x in domain n, okay. So for every y there is some x we need to show, okay. So after writing that we can say f is 1 1 and onto, therefore f inverse is equal to x minus 3 upon 4. So while writing the inverse, whatever the equation 1 we have got, we need to replace y with x, okay. So here whatever the y value is there, we need to replace it by x value, okay, and write down the value inverse of the function, okay. So once again, see the last step. See, here we have got in equation 1 we have got x is equal to y minus 3 upon 4, okay. This x, when we are writing the inverse of the function, okay, y minus f inverse of x is equal to, okay, where there is y you need to replace it by x, so x minus 3 upon 4 will be the inverse of the function, okay, will be the inverse of the function. So this is the method, okay. So this is how we can show the function is what, uh, how inverse of the function. So we have found out the inverse of the function. Now to show invertible, okay, to show invertible, okay, there is another method also, that is the composition of two functions. So using composition of two functions, hello, okay. So using composition of two functions, we can show the function is invertible. Okay, so this is the first part of this 5 mark question. So here there are two steps. The first step is you need to show the function is a 1 1 function, and then we need to show the function is onto, and since it is 1 1 and onto, inverse of the function will exist, and then we need to find out the inverse. So we have found out the inverse. F inverse of x is equal to x minus 3 upon 4. Okay, so this is one method. Okay, this is the first method. Next we will try to show the function is invertible with the method 2 also. Okay, with the method 2. Okay, so we will discuss the method 2. So in method 2, what we need to do is we are making use of the composition of two functions. Okay, so same type. So if they ask you to just check whether it is 1 1 and onto and find the inverse, the method 1 is absolutely correct. Okay, you can go with that method. Or now if you want to show it is invertible, you can use the first method, and also you can, so in when invertible is used, we can we better to go with composition of two functions. Okay, so here again we are considering the same explanation here. So here what we are doing is let y be any arbitrary element again. So let y be any arbitrary, okay, arbitrary element. Okay, y be any arbitrary element of codomain y. Okay, of codomain y. Okay, of codomain y. So by definition, okay, by definition we need to write the value of y. It's already given in the question. So by definition, okay, y is equal to 4x plus 3. Okay, 4x plus 3 for some x, for some x in the domain n, in the domain n. Okay, and then we need to convert it in a form of x. So consider y is equal to 4x plus 3. So x will be equal to 6. Y minus 3 will be equal to 4x, or x will be equal to y minus 3 upon 4. Okay, and whatever this function we have got, see this equation we have got, equation, actually this is the function, and this is the equation 2 what we have got. This equation 2 is actually the inverse of the function. Okay, is inverse of the function. So we will define it. So define, see whenever we are defining the inverse, we are taking the reverse of this function. So here in the question the function is from n to y. We need to define another function g from what, y to n. Okay, we need to define it from y to n. Okay, so define g from y to n by, see, g of y. Okay, g of y. So when we are making use of y, we are replacing this as y minus 3 upon what, 4. So whatever equation 2 we have got, that will be equal to the function g of y. So g of y is equal to what, y minus 3 upon 4. Okay, now to check it is invertible. So this is the answer for find the inverse of y. Okay, so we have already found out the inverse. So whatever this function is there, so to check it is uh, actually invertible, we need to show the composition is equal to identity function. Okay, so first what we are doing is we are considering g composition f of x. Okay, so g composition f of x will be equal to g of f of x. Okay, so g of f of x. So g of f of x, where there is f of x, replace it by the value f of x plus 3. Okay, now this step is important here. See, the function g of y is equal to what, y minus 3 upon 4. Okay, so where there is y in the function g of y, you need to replace it by the complete f of x value, that is 4x plus 3. So this will be 4x plus 3. In place of y I have written 4x plus 3 minus 3 upon what, 4. So on simplifying it, plus 3 minus 3 will cancel, 4x upon 4, which will be equal to what, x. Okay, so it will be equal to x. Next we need to find out uh, G composition f of x. Okay, so next part what we need to do is we need to find f composition G of y. Okay, so here again by the definition it will be f of G of y. Okay, and the value of f of G of y is G of y. What will be the value? Say G of y, the value it's already there. We have written the equation y minus 3 upon what 4. So the value of G of y is y minus 3 upon 4. Okay, so by replacing this value with x, so see the f of x value is 4x plus 3. F of x value is what? 4x plus 3. So in place of x, we need to replace this value y minus 3 upon 4. Okay, so here what we have to do is 4 into, in place of x we will replace it by y minus 3 upon what 4 plus 3. Okay, so 4 and 4 will cancel. Next step we write y minus 3 plus 3, and plus 3 way and minus 3 will again cancel off. So y, it will be equal to y. Okay, so we have shown G composition f is equal to I of n. Okay, and f composition G is equal to I of y. Okay, so this n indicates the domain, and this y indicates that is y, it indicates the codomain. Okay, so we have shown G composition f results into a element of domain set. F composition G is equal to what? I of y. Okay, therefore we can say now f is what? F is invertible. F is invertible. Okay, and since f is invertible, we can write f inverse is equal to what? G. Okay, so inverse of this function is the function G. So G is nothing but the inverse of this given function. Okay, so this is the method to. Okay, so if they ask only to find out the inverse or check whether the function is 1 and 2, we need to make use of the first method. Okay, and when they are asking you to prove the function is invertible, we can go with this definition. Okay, we can go with this definition, that is composition of two functions. Okay, G composition f and f composition G. So you need to show G composition f is equal to x and f composition G is equal to y. Therefore the function f will be what? Invertible function. Okay, so once again, question is little bit lengthy. Okay, and here the statements are very important. Okay, y must belong to what? Codomain. This sentence is very important, and x must be present in what? Domain. So most of the students don't consider the values of what? Y. Y, what is y, what is x? So without defining y and x, you can't begin with the solution. So better define what is y and what is x, and then you can proceed with the next steps. Okay, so the first is statement and finding out x value and defining gy. So this is the first step. Okay, so this first step is common for every question now. Okay, so if you want you can mark it and tick. Okay, so this will be the step number 1. Okay, so this is step 1, yes, 1. Okay, up till here, and then to find out G composition f of x, you can consider it as step number 2. Okay, and then here step number 3 for f of G of y. Okay, step number 3, this is the step number 3, and then the last step you need to write f is invertible, therefore f inverse is equal to G. Okay, so 5 marks. Okay, so 5 mark the question is. So 4 steps you need to do, these 4 steps. Okay, or the first step you can break it into 2 parts. Up to equation 1, it's already given in the question, that is step 1, and this you can consider it as step 2. Okay, hope the first example is clear. If the first example is clear, the next example, all the examples are similar types. Okay, so we will discuss the second question now. Okay, so see here the function is a linear function. The calculation was bit easy. But when the function given is a quadratic function now, okay, so little the calculation part will be lengthier. So try to remember the steps. Okay, or try to understand the steps, what steps we are doing in the first step 2, step 3 and all. Okay. Step ನೆನಪಿಟ್ಕೋರಿ step ನೆನಪಿಟ್ಟು ಅಂದ್ರೆ you can easily solve it. Okay, so be in the rough book or whatever the book and pen you have taken, in that you write and take the steps. Step 1 is finding the x value, that is defining the function g of y. Then step number 2, finding g composition f, and then step number 3, f composition g, and then we need to show f is invertible. Okay, so we'll begin with the second question now. Second question. This is the question number 2. So only two patterns are there. Actually, three patterns are there. One is linear function, next is quadratic function, and another one is a fractional. Okay. Another one is the function is in form of a rational function. Okay. So three types are there. So in every type one I will be discussing. Okay. Other example you all try to solve it for homework. Okay. So we will be continuing with this second example, example number 2. So see again the example, the question is same. Okay, let f be a function from n to r, be a function defined as f of x is equal to 4x square plus 12x plus 15. Show that f n to s, where s is the range of f, is invertible. So we need to show again the function is what, invertible, and also find the what, inverse of f. Okay, also find the inverse of f. Okay, so same question. So again the same procedure we will be following here, and finding the inverse of the function, and also we will be showing the function is invertible. Okay, we will be showing the function is invertible. Okay. So in the solution, same again, the first sentence remains the same. Okay, let y be, okay, let y be any arbitrary element. Okay, let y be any arbitrary element, that is any element. Okay, arbitrary means any one element of range of f. Okay, of range of f, and then by definition. Okay, by definition, see what is the definition given there, y value. Y is equal to what, 4x square plus 12x plus 15. Okay, for some x in domain, for some x in domain n, in domain n. Okay, and then now here we need to write the given function in terms of x. Okay, so this step is very important here. So converting this function in terms of what, converting this function in terms of x. So in linear function the process was very easy, but in this case we consider y is equal to 4x square plus what, 12x plus 15. Okay, so here one simple rough work we are doing first. Okay, so in the rough work what we are doing is we are considering the middle term here. Okay, the x term, see the x term. Okay, just this is the rough work. See here, this will be, you try to compare the given quadratic equation with the form a square 2ab plus b square. Okay, if minus sign is there, make use of minus sign. So when positive sign is there, we are making use of this formula. So a plus b whole square. Okay, so we know a plus b whole square is equal to what, a square plus 2ab plus b square. So these first two terms will be given. The third term, so to make it a perfect square now, to make this a perfect square, we need to equate this, the middle term, that is 12x term, okay, with the 2ab. So equate it with 2ab. So 2ab is equal to what? 12x. Okay, 2 into, say in place of a in the function, in place of a, it is 4x. Okay, but actually what will be a will be square root of 4x. This is 4x square, it is a square, so a will be equal to what? A will be equal to 2a, 2x. So in place of a, what I will be doing is I will be substituting 2x into b is equal to what? 12x. Okay, or b will be equal to 12x divided by, we want b term, so 2 into 2 it will be 4, 4x. Okay, and when we simplify, b will be equal to 3. Okay, b will be equal to 3, and once we get b is equal to 3, we need to square it. So b square will be equal to what? B square will be equal to 3 now. So and we have to add that term here. Okay, so to convert this given equation, equation 1, okay, to convert this given equation in terms of, okay, see, this is the given equation 1, we need to convert this equation in terms of x. Okay, that is the main step. So here what we are doing is we are adding and subtracting 3 square. Okay, so add 3, add and subtract. Okay, add and subtract 3 square. So when we do this, we get y is equal to, see, 4x square plus 12x plus 3 square minus 3 square plus 15. Okay, and how did we obtain 3? By equating the middle term to 2ab. So equate the middle term to 2ab and find out the value of b. So how to find out the value of b? We have done it in the rough work. Okay, there. And then now directly see this first 3 terms, it will form a perfect square, 4x plus 3 whole square. Okay, this will form 4x plus 3 whole square. Now see, minus 3 square, minus 3 square is minus 9, minus 9 plus 15, it will be plus 6. Okay, so this will be the value of y, and again we need to convert it in form of the function. So we want the equation for x. Okay, so ಇಷ್ಟು ಮಟ್ಟ ಎಲ್ಲರಿಗೂ ಅರ್ಥ ಆಗಿದೆ. So ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ ಅಂದ್ರೆ ಇದು rough work, you pay attention on this rough work, so you will understand how we are getting. So we have converted y ಗೆ ಏನ್ ಮಾಡಿದ್ದೇವೆ ಅಂದ್ರೆ perfect square plus some number. We have converted it in a form of perfect square plus some additional constant. Okay, so now to get the value of x, we need to simplify this. So y minus 6 will be equal to, see, y minus 6 will be equal to 4x plus 3 whole square. Okay, or see, 4x plus 3 will be equal to root of, okay, it will be equal to root of y minus 6. Okay, it will be equal to root of what? Y minus 6. So we are considering the positive value, okay, as the domain is a natural number. Okay, so no need of considering the negative value, only consider the positive value. Okay, so see, 4x plus 3 is equal to y minus 6, or see, on further simplifying we get 4x is equal to root of y minus 6. Okay, root of y minus 6 minus 3. Okay, or x will be equal to root of y minus 6 minus 3 whole divided by 4. Okay, and this will be our equation number 2. Okay, equation number 2, and using this equation we need to define now. Okay, so we need to define g. Okay, so here we are defining g from what? S to n. Okay, we need to define g from S to n, range into domain. Okay, define g from S to n by make use of equation 2. So this will be g of y. So g of y will be equal to root of y minus 6 minus 3 divided by 4. Okay, y minus 6 minus 3 divided by 4. This will be the value of g of y. Okay, so this is our equation number 3. Okay, equation number 3. Okay, now to show it is invertible, so this all procedure was just to find out the inverse of the function. Okay, so we have shown it, we need to show it is invertible. So to show it is invertible, okay, we need to make use of the composition of two functions. Okay, so those who are noting it down, you can take a screenshot till here. And then we will do the next step, and those who will watch it online later, okay, you can follow the video. Okay, so the next step. So two steps are there now here. Okay, so further we need to do another two steps. That is, first we need to find G composition F, and then we need to find F composition G. Okay, so we need to show G composition F and F composition G. Okay, so here we will continue with the first part. Okay, so we require this G of Y function. We will use it to simplify. Okay. So see here on the first part, what we will do is we will be finding out G composition F. Okay, G composition F of X. Okay, so G composition F of X, first we will be finding G composition F of X will be equal to G of F of X. Okay, it will be equal to G of F of X. So here I will write down, see the inverse function also I have written, and also I will write down the Y value. See Y value, after simplifying we had got it in a form of a 2x plus 3 whole square plus 6. Okay, so we had obtained 2x plus 3 whole square upon what? 6. Okay, so this was the value we had obtained. Okay. Okay, so yes. So there I had written, see, 1 minute. There was a mistake there. I had written 4x plus 3, but it is actually what? 2x plus 3. Just note it down. So it must be 2x plus 3. Okay, and here the denominator will be 2. Okay, here the denominator will be 2. Just make a correction if you have taken a screenshot, or if you are copying down it directly. This must be 2. Okay, it must be equal to 2. Okay, so the equation 2 what you have written, okay, just correct it there. Instead of 4, replace it by 2. Okay, now we will continue with the further. So we need to show G composition F of X is equal to, so say G of F of X, keep it as it is. So G, you keep it as it is. F of X value we have already got, and that is 2x plus 3. Okay, 2x plus 3 whole square plus 6. Okay, and this we need to substitute in place of y in the equation 3. Okay, so here equation 2 and equation 3 are playing an important role. So in place of y, we need to replace this value 2x plus 3 whole square. Okay, so say in the equation 2, where 3, where there is y, replace with this value, that is root of, in place of y I will be writing 2x plus 3 whole square plus 6. So this is y value. And see, in under root, in place of y I have written this function. Okay, then we have minus 6. I will give minus 6 as it is. Minus 3 whole divided by 2. Okay, whole divided by 2. Okay, so here what I have done is, in place of y, see, in place of y I have replaced this function 2x plus 3 whole square plus 6. Okay, so on further simplifying, see, plus 6 and minus 6 will cancel off. So under the root, see, under the root what will remain? 2x. Okay, 2x plus 3 whole square will remain. Okay, minus 3 upon what? 2. So again, square and square root will cancel off. So the remaining term will be 2x plus 3 minus 3 upon 2, plus 3 minus 3 will cancel off. So 2x upon 2, it will be equal to x. Okay, so we have shown G composition F of X is equal to what? X. Okay, next we similarly we need to show F composition G. Now we need to prove F composition G. Okay, so F composition G of Y. Okay, we need to prove F composition G of Y. So I will do it here. So F composition G of Y will be F of G of Y. So where there is G of Y, replace the function. The function is root of y minus 6 upon 3 whole divided by what? 2. Okay, so now this function we need to replace in x. Okay, so where there is x, we need to replace this. So this will be equal to, see, in place of x, 2 I will keep it as it is. In place of x, I am writing this function. Okay, root of y minus 6, okay, minus 3 whole divided by 2. So y x I have replaced this, plus 3, we need to square it. Okay, we need to square it, and plus 6. Okay, so see, in equation 2 where there is x, in place of x I have replaced y value. Okay, so I have replaced g of y value. Okay, and again we need to simplify it further now. So on further simplifying, see, pay attention. On further simplifying, we get, okay, so ಇದಕ್ಕೆ simplify ಮಾಡಿದ್ದು ಅಂದ್ರೆ ಮುಂದೇನು ಸಿಗ್ಬೋದು ನಮಗೆ. See, 2 and 2 will cancel. Okay, so minus 3 and plus 3 will also cancel. So in the bracket only y minus 6 whole square term will remain, and plus 6 will remain. So square and again square root will cancel out. So it will be y minus 6 plus 6 plus 6 minus 6 will also cancel, and the final answer will be equal to y. Okay, so we have shown that. Okay, so we have shown that f composition g, okay, is equal to I of s, and g composition f is equal to I of n. Okay, so we have shown this. So we can say f inverse, f is invertible and f inverse is equal to g, and g we have already obtained here. Okay, so this is the last step we need to write. Okay, we need to write uh, the function is invertible and f inverse is equal to g. Okay, so the example is a little bit complicated. Okay, so you need to practice it 2 times, 3 times. Okay, either 2 times, 3 times you practice the simplification. The simplification is not easy. Okay, if any doubt is there, you can send a message to us. Okay, we will try to discuss that. Next, we will discuss the next example now. So the next, see, the this we have simplified it for a quadratic. Okay, the function over here is a quadratic function. Similarly, the next question is also consisting of a quadratic function. So there I will be showing you only the simplification part. Okay, rest of the part, that is g composition f of x and f composition g, both you all try to do it once again. Okay, we'll discuss the next question, question 3. Participants, just mute your audio. Okay. Okay, so next question is, okay, so this question you all tried for homework. Consider f is a function from r plus, okay, f is a function from r plus to r plus to 4 comma infinity, given by f of x is equal to x square plus 2. Show that f is invertible and write it inverse. And this question is simple, you will try it for homework. We will be discussing the next question. Okay, we will discuss the next question. Okay, so this question, yes. Okay, so this the previous question and this question have occurred many times. They have occurred two, 3 times in the board exams. Okay, so here in this again we will just, I will be trying to, okay, I will be helping you out how to write down g of y, and rest of the part, that is the composition of two functions, you all try to solve on your own. Okay, so see in the solution. So again we have got the value of f of x. So f of x, so the same steps you need to repeat via for 5 marks. The description you need to mention, let y be any arbitrary function belonging to the range. Okay, and then by definition we have x in the domain. Okay, x in the domain. That same step you need to write. So here just I am helping you out with the simplification. See, 9x square plus 6x minus what it is, 5. So again I told you to write down the middle term. See, the middle term here is 6x. So equate it with 2ab. So 2ab is equal to what, 6x. 2 into, in place of a we have to take the square root of the first term. See here, the first term is 9x square. Okay, 9x square, square root of 9x square will be 3x. So it will be 3x into b will be equal to what, 6x. It will be equal to 6x, or b will be equal to 6x upon 6x, which will be equal to 1. Okay, so we have obtained b. So we need to add 1 square, and okay, so this function we can write it in the form of 9x square plus 6x, okay, plus 1 square, minus 1 square, minus 5. Okay, so on simplifying we get 3x plus 1 whole square, and minus 1 minus 5 is a minus 6. Okay, minus 6. So this is the value of y. So y is equal to 3x plus 1 whole square, minus 6. And this function we can consider it as 1, and this we need to convert it in form of x. Okay, so to convert it in form of x, now we get y plus 6 is equal to 3x plus 1 whole square, or 3x plus 1 is equal to root of y plus 6, or root of y plus 6 minus 1 will be equal to 3x. Okay, or see, x will be equal to 1 by root of y plus 6 minus 1 whole divided by 3. Okay, and see, this function will be the g of y function. So g of y will be equal to root of y plus 6 minus 1 divided by 3. Okay, minus 1 divided by 3. And see, the same function is given here. So already the inverse function they have given, we need to check this function is the inverse. Okay, so f inverse of y, see, whatever we have obtained, and the same function is given in the question. F inverse of y is equal to root of y plus 6 minus 1 upon 3. Okay, upon 3. Yes, so we will be discussing the last question for today's class and then stop. So after this, the same two steps you need to do. You need to find G composition F and F composition G. Okay. Okay, so this in this question, see, show that again the same question. So this is a partial means fractional part question. You will try it for homework. This question also has occurred one time in the exam. Next we will be going to the last type. So see, if the question is not on invertible, the question will be check whether the function is 1 1 and 1 2 function. Okay, so this will be the question. So here what they have given, see, they show that f minus 1 to 1 to r given by f of x is equal to x upon x plus 2 is 1 1. Okay, so first we have to show it is 1 1, and then find the inverse of the function, that is minus 1 to 1 and range of f. Okay, so first we need to show this function is a 1 1 function. So the previous question was also a rational function, which you all try, and see, this question is also the similar question, x upon x plus 2, and the previous question, see, the function is only in different form. There only the function is different, rest of the steps are same. It is 4x upon 3x plus 4. Okay, so the procedure is same, only and the function is different. Okay, so same procedure we need to apply. So first what we will be doing is we will try to check this function is what, a 1 1 function. Okay, so to show it is a 1 1 function, again what we need to do is we need to consider f of x1 is equal to what, f of x2, what we have done in the first case. Okay, so write down the first given function. F is a function from minus 1 to 1 to r. Okay, given by f of x is equal to x upon x plus 2. Okay, x upon x plus 2. So first we need to check it is 1 1. Okay, to check it is 1 1, we are considering f of x1 is equal to what? F of x2. Okay, so f of x1, it will be x1 divided by x1 plus 2 is equal to x2 divided by x2 plus 2. Okay, x2 plus 2, cross multiply. So when we cross multiply, we get x1 into x2 plus 2 is equal to x2 into x1 plus 2. Okay, so on simplifying, we get x1 x2 plus 2 x1 is equal to x1 x2 plus 2 x2. x1 x2 x1 x2 will cancel off. So 2x1 is equal to 2x2. 2 and 2 will cancel off. So we get x1 is equal to what? X2. Okay. So x1 is equal to x2. So f of x1 is equal to f of x2. So you need to write the definition of 1 1. F of x1 is equal to f of x2 implies x1 is equal to what? X2. So therefore the function f of x is what? A 1 1 function. Okay, so 1 1 function. So next they are asking again to find the inverse of the function. Okay, so to find the inverse only they are asking us to find the inverse. They are not asking us to check whether it is invertible. Okay, so here what we need to do is to find out the inverse. Just we need to write down the given function. So see, consider y is equal to x upon x plus 2. Okay, x upon x plus 2. Okay, or see, x plus 2 into y will be equal to x, or xy plus 2y is equal to what? X, or 2y will be equal to x minus xy. Or on simplifying, what do we get? See, x is common, it will be 1 minus y. Okay, 1 minus y. Okay, so we get here 1 minus y. Okay, x into 1 minus y. So this is equal to what? 2y, or x will be equal to, so x will be equal to, see, 2y upon 1 minus y. Okay, so again we need to write down, okay, the inverse of this. So whatever this equation we have got, using this we can write the inverse of the function. So you need to write down, let y be, okay, let y be any element. Okay, we need to write the definition of onto function. Okay, so let y be any arbitrary element. Okay, arbitrary element. Let y be any arbitrary element of range of f. By definition, y is equal to, see, y is already given in the question, x upon x plus 2. Okay, for some what? For some x. Okay, so by definition there is y for some x in what? For some x in a domain, such that x is equal to 2y upon 1 minus y. Okay, so we have shown it is onto. Therefore last we need to write the inverse of this function. So f inverse of x will be equal to, so see, whatever the equation 2 we have obtained, this equation 2, and this is our equation 1. Okay, equation 1. So where there is equation 2, there in place of y you replace it by x. So we get 2x upon what? 1 minus x. Okay, so this is the inverse of the function, and that is 2x upon 1 minus x. Okay, so we have discussed the 5 mark question, okay, on this chapter from relation and function. So in the next class we'll be discussing some more questions, okay, on the next chapter, that is inverse trigonometry. Okay, so we'll meet you in the next class. Bye.